Okay, so day 2 with the equation of a circle. Remember, you were required to know two things about the circle to write its equation. You need to know its center, which we use the variables h and k to represent those coordinates, and you have to know the radius. And so when you use the equation of the circle, remember there's subtraction in those parentheses because you're finding those lengths of those sides of the triangle, remember from yesterday, so that's where that subtraction comes from. And then using the Pythagorean theorem, this is your a squared plus your b squared equals your c squared. So you put in your center and your radius. Don't forget to square your radius, and don't forget these signs are the opposite of what h and k are. So if they are positive, you'll have subtraction here. If they're negative, you'll have addition in the formula. So let's look at the back of your discovery from today. Number 9 says to write an equation. You're given the center as -1, 2 and your radius of 2 units. So this is your h and k, and this is your r. So writing that equation, you would have x minus h, and x minus a -1 makes that x plus 1. Don't forget your exponent of 2. Plus your y minus k of 2, so that stays subtraction. Don't forget the squaring, equals the radius squared. So 2 squared would be 4. There's the equation of that circle. Number 10 says we can also write the equation of the circle if we're given the center and a point on the circle. But remember, you have to know the center and the radius. So if you're given the center as 4, 3, this is your h and k value. So you already know part of your equation of your circle is going to be x minus 4 squared plus y minus 3 squared, using that center as h and k. But we need the radius to complete that equation of the circle. So we're given a point on the circle. So we're going to find the radius. The radius is just the distance between the center and any point on the circle. So we're going to use our distance formula using these as my 2 points. Now it doesn't matter which one you want to declare as your first point and your second point when you put it into the formula. So you're going to have the change in your x coordinates. So you would have 6 minus 4, and don't forget you're squaring that, plus the change in your y coordinates, -1 minus 3, and you're squaring that. So don't forget this is subtraction, just like it is in the formula for the equation of a circle. So 6 minus 4 is 2. 2 squared is 4, plus -1 minus 3 is -4, but when you square it, you get positive 16. So we get the square root of 20 when we add the 4 and the 16. That's my radius. I really don't have to simplify that, even though we know the square root of 20 can be simplified. Since it has a perfect square factor of 4, we could simplify it and write it as 2 square roots of 5 as our radius. Because we are going to do what to our radius when we put it in the formula? We're going to square it. So it's actually easier to leave it in the unsimplified form to write the equation of the circle. Because the square root of 20, when I square it, the squaring and the square root just cancel each other out. So I'm just left with 20 here. Now you could do that with the simplified version too. When you square 2 square roots of 5, remember that means 2 square roots of 5 times itself. So 2 times 2 is 4, and the square root of 5 times the square root of 5 is 5, and 4 times 5 is 20. So either way, it's just easier to have it in the unsimplified form, since you're just going to be squaring it. The squaring and square root cancel each other. So I have to know my radius before I can write the equation of the circle. So you're going to have to find the distance between the center and a point on the circle to find the radius. Alright, so what if you were only given the endpoints of the diameter and you were asked to write the equation of the circle? So we would have to know the center and we would have to know the radius. Neither one of those things are given to us. But we know that a diameter goes through the center of the circle, and it's the halfway point is the center, because this is a radius and that's a radius, and they have to be congruent to each other. So all we have to do is find the midpoint of these endpoints of the diameter, and that'll give me my center point. So remember, to find midpoint, you're just averaging your x's, which means to add them and divide by 2. And average your y's, add them and divide by 2. So negative 2 plus 4 is 2, but when you divide it by 2, you get 1 for the x-coordinate. 5 and negative 7 are negative 2. Negative 2 divided by 2 is negative 1. So this is the point halfway between this. Negative 2 plus 3 is 1. 1 plus 3 is 4. 5 minus 6 is negative 1. Negative 1 minus 6 is negative 7. This is halfway between these 2 points. So now I know the center. This is my h and k value. So I now know part of the equation of the circle would look like this. Remember, opposite sign, opposite sign. Don't forget the squaring and the addition. But I don't know what to square for my radius yet. So you have 2 options here to find your radius. Some students think it would be easier to find the distance between these and take half of it, but a lot of times that's more difficult because this will be a radical answer. So you don't want to do that. You want to take your center point and find the distance between it and either one of those points. It doesn't matter which one you pick because you're going to get the same distance. Obviously, your radius cannot change. So you need to declare one is your first point and one is your second point and find the distance between them. So I want the square root of the change in my x, so 1 minus a negative 2 squared plus the change in my y, negative 1 minus 5 squared. Oops, sorry. So we know 1 plus 2 is 3, and when we square it we get 9. And negative 1 minus 5 is negative 6, but when we square it we get positive 36. These numbers are always positive because you had to square to get them. So we add those together and we get the square root of 45. Now again, this simplifies. 9 is a perfect square factor of 45. But since I'm just going to square it when I put it into the equation, it's easier to leave it in the unsimplified version. So since my r is the square root of 45, r squared would be the square root of 45 squared. So the squaring and square root cancel, leaving me with just 45. Now number 12, well, I just did that whole thing. So we found the center point, and now how do you find the radius? We did that. So now we have the equation of the circle is here, using the center and using the radius squared. Alright, so number 14 says, I think it's supposed to say given the equation of a circle, graph the circle on the following graph. So you want to write the center. Remember, it's a point, so you always put it in parentheses. Remember, your x-coordinate is the opposite sign of this number, so it's positive 2, and your y-coordinate's the opposite sign of that number, so it's negative 3. Remember, this is not your radius, that's the radius squared, so my radius is the square root of 9, which is 3. So now I'm ready to graph. I'm going to plot my center point at 2, negative 3. I'm going to use my radius of 3 to go 3 units to the right, 3 units up, 3 units down, and 3 units to the left. And then you can just use those points to draw an oh so beautiful circle like I just did. Alright, so the next problem is not on your notes, but just wanted to go over the fact that when you're given fractions, it really doesn't make the problem that much more difficult. Remember, the center point is always your h and k. And so if you don't have a parentheses for your x, remember that means that your h was 0. So x squared came from x minus 0 squared. So the x-coordinate of my center would be 0. The y-coordinate is just the opposite sign of this number, so it would be a positive 3/4. The radius is the square root of this. This is this r squared value. So when you take the square root of 25/4, even though it's a fraction, it's not hard because the numerator and the denominator are both perfect squares. The square root of 25 is 5. The square root of 4 is 2. So my radius is simply the fraction 5/2. This question says, which of the following is the correct graph for the equation? So first of all, I would notice that its center point would have to be +1 and -4. +1, -4, that center's correct. +1, -4, that center's correct. And this one's not because it goes to -1, 4. So we can eliminate C based on the center. Now remember, this is your radius squared, not your radius. So you see how this circle used 5 as the radius? That would be incorrect. The radius is actually the square root of 5, like is pictured in A. So A would be the correct graph. I don't know if I had that off of the screen the whole time or not, but there you go. All right, so you're ready for worksheet 12, and that'll be due tomorrow. See you then.